Hi, everybody. This is Chapter 6, Part 2. So, welcome back. We are mainly going to be doing some review in this part. We're going to review concepts from Chapters 3, 5, and 6. So we'll get back to some of the basics on 6 again, but we're going to do some review from all of those chapters in preparation for the exam that's coming up. So, first, let's start with this review. So I got these researchers, and they published a study, and they think that people who listen to Mozart music are more attractive. That is, listening to Mozart makes you more attractive. Several different labs tried to reproduce the results of the original Mozart study, didn't get the same thing. Which of the following most likely happened? Okay, now in this one, it's asking if you remember what a type 1 and a type 2 error are. So in this case, when we're looking at the hypothesis, Mozart makes you more attractive, the null hypothesis is that Mozart doesn't make you more attractive. Mozart has nothing to do with being attractive. So that's the null. A type 1 error is when you reject the null when the null is true. So when you reject the null, you say that Mozart makes you more attractive when it really doesn't. So type 1 error is when you reject the null when the null is true. So that would be saying that Mozart makes you more attractive when it doesn't really do that. So that means in the original study, they found that Mozart makes you more attractive. That means that if they were wrong, they made a type 1 error in the original study. The different labs after that did their own studies. Those would be separate studies. They tried to reproduce the results and they didn't find it. If they didn't find it, then that means that they failed to reject the null. So if they failed to reject the null when the null is false, failed to reject the null when the null is false, that would be a type 2 error. So the original researchers, they could have made a type 1 error. The researchers that were trying to reproduce, they could only have made a type 2 error. So when you're looking at these, you have to decide, what are we talking about? In this case, the original researchers could not have made a type 2 error. So we already know that C and D are not possible. All right? We know that they could have made a type 1 error, so A and B are possible. But we got to get the definition right. So A says the original researchers made a type 1 error and were incorrect when they rejected the null hypothesis. If that is the case, then A is the right answer. Meaning, if the null hypothesis is actually true, then they made a type 1 error. And since other labs tried to reproduce, they couldn't do it, it seems likely that A is the correct answer. The original researchers made a type 1 error and were incorrect when they rejected the null. All right. What we're going to do then is let's take a look at this particular study and talk about different iterations of it. So remember, the hypothesis is listening to Mozart makes you more attractive. That means that we need to figure out what kind of study this is. Well, what kind of study it is depends on several different things. So what we know is that they have a hypothesis. The hypothesis is listening to, and let's say it's classical music, okay? Listening to classical makes you or changes your attractiveness level. Right? Okay. We don't know what kind of study it is. And by study, I mean, we don't know if this is a correlational or an experimental design. We don't know that yet. We know it's not a frequency, right? It can't make just a frequency claim because a frequency claim only measures one variable. That's all that's going on. We know we have two variables here. Listening to classical music affects attractiveness. Now, if they really mean that it makes you more attractive, meaning that listening to classical music causes you to become more attractive, then they have to run an experiment to test that claim. If this, let me show you what that looks like in the, it looks like this. So it's just one arrow going one way. In fact, just to make it clear, let me get rid of that one just because I accidentally had an extra mark. If they're doing that, then they have to have an experimental design. An experiment is one where you manipulate the independent variable and you measure the dependent variable. The independent variable is the one that causes the change in the dependent variable. That means that listening to classical music is the independent variable because it's causing a change in attractiveness. Attractiveness has to be the dependent variable. Now, in this case, both of these are the circles. These are the conceptual variables. We don't have any operationalizations on here yet. We don't have any way of being real life. What does it mean to listen to classical music? And in real life, what does it mean to be attractive? Okay, we don't have that yet. If we were doing an experiment, then it has to be a manipulation of the independent variable. I don't know why it gave me an extra line there. Let's get rid of this to fix it. If that's the case, then this is the manipulation, and it's got to change the independent variable. It's got to go from square to circle. It's got to have a manipulation. Now, when we talk about manipulations, we always have to have at least two groups, what we call levels of the independent variables. So one level could be no music, right? And another level could be Mozart. That would be two levels of the independent variable listening to classical music, right? One level has none, and the other has Mozart. We could have an extra level, another level, a third group, where we have nothing, Mozart, and then we have another that is going to be listening to a different amount of classical music. And so in this particular case, let's say that's going to be a Beethoven group. Right? That would mean that we have three levels of the independent variable listening to classical music. Okay? So let's say that each of those are going to listen they're going to be in a room for 30 minutes where they listen to nothing, they listen to Mozart, or they listen to Beethoven. So those are our three groups. And then attractiveness is a dependent variable. Dependent variables have to be measured. They have to be measured. There's no choice on that one. It has to be a measurement. We can measure this in a variety of different ways. Remember, we talked a lot about different kinds of measurements: self-report, observation, physiological. So let's in this case have our attractiveness level be by observers. Have observers rate people on a scale from 1 to 10. Okay? This is a diagram of an experiment. We have three levels of the independent variable. We have three separate groups. People are assigned to either listen to no music at all, Mozart or Beethoven for 30 minutes, and we think that that's going to change this variable listening to classical music, and I think that's probably a pretty good bet that it does. And we think that listening to classical music changes attractiveness, and we're going to measure attractiveness by having observers rate the people's attractiveness on a scale from 1 to 10. Now, if you remember right, what we've been talking about mostly in chapters 5 and 6 has to do with the measurement side, which is this stuff over here. What we talked about in chapter 3 has to do with this whole diagram, everything, right? Whether it's a correlational design or experiment, the different kinds of validity, etc. This is an experiment. If we were going to have it be, if it was going to be a correlational design, it would look different. I'm going to just put this correlational design here in the corner. It would look something like this. It would be a circle, a circle, a square, and the correlations are two measurements. We would measure, and then we'd have the arrows going both ways. That's a correlational design. If you remember, correlation does not equal causation. So if their actual hypothesis was that they think that listening to classical music causes the attractiveness to change, then they have to do an experiment. All right? So let me get rid of this correlational design, even though it's still good. All right? It's still good to know what a correlational design is. Let's look right here. When you're looking at this, what would be a question of construct validity? What is a question of construct validity on this diagram? The only question of construct validity is whether the observer's ratings really do measure attractiveness. That is the only question of, well, it's not the only question of construct validity. Technically, whether or not this manipulates listening to classical music is also a question of construct validity. But the correct answer is that whether the observer's ratings are really measuring attractiveness. That's the measure of construct validity. So measurements have construct validity whether the measure really measures what it claims to measure. Manipulations have construct validity if the manipulation actually manipulates what it claims to manipulate. It's the connection between the circle and the square. That is a question of construct validity. The question of internal validity is which one? Internal validity is a question of whether or not listening to classical music actually causes attractiveness change, or if it's something else. So in an experiment, you have internal validity if the independent variable actually causes the change in the dependent variable. If the independent variable actually causes the change in the dependent variable, you have good internal validity. If it's not, if your independent variable is not the one that's actually changing the dependent variable, then you have poor internal validity. All right. Statistical validity, which we'll get to better in a different chapter, is whether or not they use the correct statistics. And external validity is, does listening to classical music really change attractiveness outside of this particular study's design in real life, in the real world, outside of the lab? That would be a test of external validity. So let's keep going with some of these concepts. Now, in this particular case, we have a measure that is an observational measure. So if we have a measure that's an observational measure, which one of these would not be a concern for our measure? Internal reliability is not a concern for this measure. The reason why is because internal reliability is only for self-report measures, particularly scales. All right? So let's talk about and remind ourselves what's going on here. The big ones that we have are, the big measurements we talked about are self-report measures versus observations. And in this case, we have an observation. So let's go and talk a little bit about scales. So a scale is multiple self-report items that measure the same concept. All right? So this is an example of a scale. These two questions, I'll circle the scale. This is the scale. This is the scale. Multiple self-report items. Here's one item. Here's two items. Multiple self-report items that measure the same conceptual variable. Okay? The question then, in this particular question, I want you to answer right now, what kind of items are in this scale? Likert items, semantic differential items, or neither? This scale is neither. This is neither semantic differential, nor is it Likert type items. These are items. Yep, these are definitely items, but they are not Likert type items and they're not semantic differential items. They are forced choice as opposed to open-ended items, but they are neither Likert items nor semantic differentials. So let's keep going with this. What about this? What kind of items are these? These are semantic differential items, semantic differential. So in this case, what they're studying is people's I guess, attitude towards survey gizmo, right? And survey gizmo is either weak or powerful. It's either inexpensive or expensive. Notice the differentiation, the poles, right? The semantic differentials, and you need to choose where they are on the scale between powerful, weak, expensive, inexpensive, good, bad, dated, modern, hard to use, easy to use. That's the semantic differential. All right? Semantic differential is a form of response format or response scale for items in a scale. What kind of scale items are these? Well, good guess. This is Likert items. These are Likert items because they have a statement. Notice how they do not end with a question mark. These are statements. And those statements then have a agreement to disagreement, right? Strongly agree, strongly disagree. So whenever you have a statement, a sentence, and then it's agreed to disagree on some sort of format, then you're looking at a Likert item. You can say Likert if you want to. I'm not gonna get you in trouble either way, but those are called a Likert or a Likert type item. All right, great. Let's go back and take a look at the some of the things that we need to be worried about with observational. Well, so just here's a quick review. Response sets are only for self-report items, and specifically forced choice self-report items. So acquiescent responding is when it's the yay saying or nay saying. It's you're always agreeing or you're always disagreeing on all of the items. Fence sitting is when you do everything right down the middle in the neutral. Those are not good for our self-report items. All right. When we are looking at whether or not, so I'm going to go all the way back to this. When we're looking at whether or not our measure, whether observers' ratings actually measures attractiveness, then we are worried about the construct validity. If you remember, under construct validity, we have several different kinds of validity that we care about. That is, we have face validity, we have content validity, criterion validity. Face validity, content, criterion validity are testing whether or not, number one, face validity. Does this appear to be measuring attractiveness? If the answer is yes, then it's face valid. Number two, content validity. Do these observers' ratings include every aspect or all the aspects, all the content of the concept attractiveness? And number three, criterion validity would be a specific behavior that should be associated with, in this case, the observer's ratings. And if that's the case, then we would have criterion validity as well. So that would mean that beyond attractiveness, we would need to be looking at a specific behavior. So let's say that the behavior that this would be associated with is having more social relationships. I guess the assumption would be the attractive people have more social relationships than unattractive people. And so we would get their ratings. We'd see if that's correlated with their social interactions, like the number of social interactions. And if the higher the rating, the higher the number of social interactions, then we would have high criterion validity. Remember, convergent validity and discriminant validity are generally used mainly for scales, when we create scales to see if the measure, the scale, remember a scale is multiple self-report items that measure the same construct, if those are correlated with other scales, other measures of similar or correlated concepts. Versus discriminant validity, is it correlated with things that it's not supposed to be correlated with? All right, when we look at observational measures like the one we have here, there's other things we have to worry about, and so let me push forward to those. Number one, is it ethical to do? And people rate attractiveness all the time in psychology, so let's hope it's ethical. Whether or not you like it is a different issue, but it does happen all the time. So what we would need to instead be worried about is observer bias, observer effects, and reactivity. So let's distinguish the difference between those three things. So imagine that you're in this study and you've got these people coming in and rating you. If the observers know what's going on, they might be biased. So let's say that I, the observer, knew that you had listened to Mozart, and I knew that the hypothesis was that Mozart makes you more attractive. Well, I might say, oh, well, I would give this person, an 8. Whereas if I didn't know that you were in the Mozart group, I might have given you a lower score, right? That's observer bias. Now, observer bias can be eliminated in several ways. It's helpful. Number one, if we have a specific scale or code book, because I have to specifically say this is what makes somebody attractive, right? So you say, all right, well, we're going to rate them on symmetry of their face, or whatever the attractiveness happens to be. If we have multiple observers and not just me doing it. But more importantly, to get rid of observer bias, you should have a masked or blind design. I should not know whether or not you listen to Mozart or Beethoven or none. If that's the case, then it would help to have me masked to your level of the independent variable. Observer effects can also be eliminated by that masked design because if I expect that you are going to be more attractive in a specific condition, then you might actually reciprocate that and change your attractiveness because of my expectation. That would be an observer effect. If you actually change in your attractiveness based off of my expectation, that would be the observer effect. And if I mask to that, then we get rid of it. Reactivity is when you just react to being observed at all, right? You feel like your control is kind of being taken away, and you act in a certain way that changes, in this case, your attractiveness, just because you're being watched. We can really get rid of some of the other ways we do this is by eliminating that with unobtrusive measures. You don't know that you're being observed, for example, and just having patience and looking at the results of specific behaviors instead of just blindly acting, right? Using a code book helps that a lot. All right, if those are the case, then that's the review that I wanted to make with this particular chapter. We covered some things that are really important to me, and so I just want to ask an opinion question right now, and that is, would you rather take a 2111 exam or a 3111 exam, meaning Psych 2111 or Psych 3111? Well, I hope you said 3111 because you're going to be taking an exam. Look for the exam review, which will be me taking you through some actual exam questions that I've used in the past for this exam and helping you with the answers as you need to. All right, thanks everybody.